In 1860, before modern machines were supposed to exist, a photograph shows something impossible. A rail-mounted excavation machine so advanced it looks like it belongs to the 1900s, not the 1860s. So either the timeline is wrong, or we've misunderstood the Industrial Revolution completely. And this is where it gets worse. Because it's not just one photograph. The accepted timeline is supposed to be simple. The 19th century begins with muscle horses, black powder, hand tools, and slow excavation. Steam exists, but in crude, localized forms. Heavy, earth-moving machinery, in the normal telling, develops gradually and then properly arrives much later, with the big leaps of the late 19th and early 20th centuries. The truly modern machine age belongs to steel-frame cities, standardized factories, internal combustion, electrical controls, and the vast engineering works of the 1890s through the 1920s. Earlier devices existed, yes, but they are usually described as primitive ancestors. Interesting experiments, isolated prototypes, not a mature mechanical world. But here's the problem. The official timeline doesn't allow this to exist. And yet the photographs do not behave like primitive ancestors. That is the problem. They show scale, repeatability, and design logic. They show articulated arms, suspended loads, guided movement, rail integration, counterweighted frames, geared housings, boilers placed for work continuity, spoil removal systems, and excavation sites organized around machine rhythm rather than human rhythm. Look at the men. They're not operating the machine and they're standing beside it, waiting. The machine dictates the rhythm, not them. So if you've never seen machines like this in the 1800s before, you're not alone. And that's exactly the problem. There is a more serious possibility. Not that the 19th century had secret science, and not that time travelers misplaced industrial equipment in old landscapes. The stronger theory is more grounded and more unsettling. It is that certain machines commonly treated as late inventions were already present in earlier decades in specialized forms, under different names, built for mining, harbor works, railway cuts, tunneling, military engineering, quarrying, drainage, and urban excavation. Later histories then simplified that messy reality into a cleaner invention story. The machine did not suddenly appear. What changed was the explanation. Start with the photographs themselves. Old engineering images are often dismissed because the labels are vague, the dates uncertain, the machine categories unstable. But there is still hard information inside them. Men provide scale. Rails provide gauge. Wagon beds provide volume. In more than one 1860s image, the suspended bucket or scoop is large enough to move a quantity of spoil that would require multiple laborers with shovels and barrows to match. The boom length is not decorative. It is proportioned for reach. The frame geometry is not improvised. It is triangulated to carry load. In some cases, the machine sits on temporary rails, laid directly into the work zone, meaning the site was planned around its movement. That is not an experiment. That is a system. Then, there is the matter of where. Machines in exhibition engravings can be misleading. Machines in live field photographs are harder to explain away. Mud accumulates in predictable places. Cable lines sag under use. Timber mats are crushed below wheel load. Boiler housings show soot patterns. Wagon queues stand where spoil would fall. This is not what a ceremonial demonstration looks like. It is what an integrated work process looks like. The machine is not visiting the site. The site exists for the machine. Patent history deepens the problem rather than solving it. Many later patents celebrated as invention moments are not patents for first creation. Most inventions weren't inventions. They were upgrades. And once a better version appeared, the older working machines were erased from the story. A fair objection has to be acknowledged here. Some of these old machines were not excavators in the strict modern sense. While many were indeed cranes adapted for Earth, some were dredging systems working in wet ground. Some were cable-suspended grabs, rather than continuous digging arms. Some photographs exaggerate scale through angle and contrast. Some dates attached to archive prints reflect publication, not capture. All of that is true, and it matters. But it does not resolve the larger contradiction. Because even if only a portion of the images are correctly dated, and even if only a portion of the machines were purpose-built for excavation, what remains is still enough to disturb the standard timeline. A rail-mounted steam-powered earth-handling machine with a controlled lifting cycle, spoil transfer workflow, and dedicated worksite layout is already far closer to later heavy machinery than the simplified story allows. We'll look at the engineering context around those photographs. The middle decades of the 19th century were not quiet. Railways were cutting through hills. Harbors were deepened. River channels were redirected. Coal and metal extraction expanded aggressively. Sewer systems penetrated old cities. Fortifications were rebuilt, expanded, or demolished. Urban grades were lowered. Embankments rose where fields had been flat. These projects required cubic volume on a scale that hand labor alone struggles to explain at the speeds often recorded. Official history answers with gangs of laborers, convict crews, immigrant navvies, military workers, explosives, and relentless time. That was certainly part of the picture. But on the biggest sites, the mathematics begin to harden. There is only so much ground that bodies, picks, mow, and carts can move in a season. Once the numbers are placed beside the photographs, the margin narrows. Now look at railway cuts. Consider the pattern of railway construction records. In reports from public works departments, the language often becomes surprisingly mechanical without becoming specific. There are references to plant delivered to a cutting, portable engines assigned to a contractor, additional boilers ordered for excavation, higher charges for lifting apparatus used in spoil removal, repairs to chains, buckets, and wagon interfaces, fuel accounts that spike during earthworks. None of these lines by themselves prove a hidden technological world, but together they suggest something important. Large projects were not documented as heroic invention stories at the time. They were documented as procurement, maintenance, and cost. Well, when a machine is ordinary inside a budget ledger, it can disappear from memory, even if it dominates the actual labor. Quarries tell a different story. Old photographs of quarries tell the same story in stone. There are pits from the 1850s and 1860s where the benches are too regular, the debris paths too organized, and the loading positions too structured to belong only to loose manual extraction. There are crane-like machines set at the lip, yes, but their geometry aligns with repeated lifting from depth. There are rails entering the cut, at angles optimized for removal. There are receiving platforms placed where a bucket swing would terminate. The arrangement is not chaotic. It is choreographed. The stone remembers. It remembers the difference between men working around a machine and men simply breaking rock. Well, but the strangest evidence comes from harbors. The most revealing cases are often the ones that seem least dramatic. Harbor works, drainage schemes, canal maintenance, river improvement. These fields sit awkwardly between civil engineering and maritime history, which is exactly why they matter. Dredging technology developed early because ports demanded it and mud was relentless. Once a powered system exists to cut, lift, transport, and discharge material at scale. The boundary between dredger, excavator, and earth mover becomes less clean than modern histories prefer. A machine working waterlogged soil from a barge can share core principles with a machine working a trench from rail. The official explanation separates them by category. The photographs connect them by function. Then the scale widens. The same visual logic appears again and again across different places. A trenching scene in one country, a harbor excavation in another, a quarry in a third, a city foundation pit somewhere else. Different names, different operators, different archives. But the same signatures recur. Elevated frames, suspended earth buckets, rail coordination, boiler support, fixed loading cycles, machine-centered staging. The pattern repeats. That is when the issue stops being a debate over one mislabeled photograph and becomes a question about industrial memory itself. If the same type of machine logic appears across sectors and regions before its accepted date of arrival, then the timeline is not merely incomplete. It is flattened. There is another reason this history may have been missed. People expect hidden truths to require dramatic concealment. Secret societies, sealed vaults, deliberate fraud. But most buried history does not vanish that way. It vanishes through institutional habits. An archive indexes a machine under transport instead of excavation. A museum collects the patent model, but not the contractor's field rig. A historian of labor studies workers, while a historian of technology studies famous inventors. And the ordinary machine in the middle belongs to neither narrative. Companies merge and discard catalogs. Engineering journals summarize improvements, but not old practice. Regional newspapers describe a machine as remarkable one year and routine the next. Bureaucracy does not need to lie. It only needs to file things in the wrong drawer for 100 years. Economics also distorts memory. Investors, manufacturers, and later corporations benefit from clean origin stories. The first true machine, the decisive breakthrough, the revolutionary design. Markets reward novelty more than continuity. So the earlier, rougher, locally modified job-specific versions are treated as prehistory, even when they already solved most of the hard mechanical problems. What survives in public memory is the version that scaled profitably, not the version that proved the concept in mud, stone, and contractor's smoke. And there is a deeper discomfort beneath all of this. Once an industrial society accepts a simple progression from crude to advanced, it begins to reinterpret old evidence to preserve that progression. A machine that looks too modern for its date is renamed. A date that feels too early is questioned. Yet a site that appears too large for hand labor alone is attributed to unimaginable manpower rather than uncomfortable engineering. The anomaly is not investigated. It is domesticated. The pattern does not disappear. It is made narratively harmless. This is why the old photographs matter so much. Photographs are not perfect witnesses. They can be cropped, misdated, staged, misunderstood. But they are stubborn objects. They preserve proportions. They preserve relationships. They preserve the fact that a machine stood there, at that scale, in that landscape, with men dwarfed beside it, with rails positioned to receive what it lifted. And once enough of these images are placed beside procurement records, patent disputes, construction accounts, and the physical signatures left in quarries, cuts, docks, and embankments, a quieter picture emerges. What the 19th century was not waiting passively for the machine age to begin. In some sectors, it was already there, working under other names, in other categories before the official story decided it had arrived. That does not mean every impossible photograph proves a lost civilization of industry. It does not mean every excavation was mechanized. It does not mean the accepted chronology is wholly false. It means something more disciplined and more difficult. It means the boundary between early and modern machinery may have been drawn in the wrong place. It means invention history may often be a history of recognition, branding, and standardization rather than first existence. It means the archive contains evidence that was never fully integrated because it did not fit the categories later historians inherited. And once that possibility is admitted, the unease spreads. How many landscapes now described as the triumph of raw labor were actually shaped by machine systems that slipped between disciplines? How many city foundations, rail cuts, quarry faces, canal widenings, and buried utility corridors were built with mechanical assistance that later memory reduced to handwork plus steam in the abstract? How many so-called first machines were only the first versions, someone bothered to honor properly. In the end, the strangest thing about these photographs is not that they look advanced. It is that they look ordinary to the people standing in them. No one in those frames appears astonished. The men lean on tools. They face the camera. They wait beside the apparatus as if waiting beside weather. For them, the machine was not an impossible object from the future. It was part of the day's work. That may be the most revealing detail of all. The real mystery is not whether heavy machine logic existed earlier than our timelines comfortably allow. The real mystery is how easily entire families of working technology can pass from use into obscurity once later categories decide what counts as an invention and what counts only as an adaptation. The photograph remains. The ledger remains. The ground remains. What changed was the explanation. So the next time you see a photograph from the 1800s, don't ask what people were building. Ask what machines were already there. Because the real history of industry may not be about invention at all. It may be about forgetting.